let's, for example, instead of 100, let's consider it is 2n, and then the answer we want to prove is at least 2n. So for 4, what was the answer equal to? For, we said 4 choose 2 times 3, right?
Yeah.
Let me take it again. For 6, it was 26 choose 3 times 3. Okay, times n. 4 choose 2 times 2, 12. Okay. So 1 part 2n choose n times n. Because it says minimum. So this is related to example. This is related to the proof. Okay. Understanding the example is these two parts are related to each other, the ideas, but this one is easier to understand. So let me explain for you the example first. Okay.
Was it? I thought it was n choose over 2 times.
Yes, if
I
we
guess it's,
consider this one n over 2, or we can consider this one 2 and to write this. Okay, without division. Okay. So for the example, let me explain for you S1, S2, S3, S4, then 6, then the whole. Okay, because we know 4 should divide the elements that are in all of them. So I consider 4 elements in all of them, okay?
okay.
So 4 elements here. Then how many elements should we consider in S1, S2, S3? At least.
We said 4 elements in S1, S2, S3, S4.
Yes, then how many elements should we consider in S1, S2, S3?
Just 3 divides S1, S2, S3. So at least 2. Or
Exactly.
at least
Yes, 2.
at least 2 elements.
So we consider 2 here, okay? And 2 also for the rest. For example, this one. 2 for this case. 2 for this case. And 2 for this case, okay? 2, 2, 2. Okay. Now, how many elements should we have in S1, S2 at least?
How many elements in S1 is 2? Right now it's 6. It needs to be. Well, it could be. Because right now it would be. It's already divisible by 2.
Yes, so 0, right? So 4,
0.
2, 0, okay? And if you consider the elements, you say, okay, 4 elements here plus 2 times 4 choose 3, which is 4 plus 8, 12, right? It's the 12 that we wanted, right? 4 choose 2 times 2 is also 12. So I want to generalize this example for 2n, okay? For example, for S1, S2, S3, S4, S5, S6. So how many elements do we have that are in all of them? Should we have in all of them at least?
6.
6. How many elements should we have that are in exactly 5 of them?
4.
4. How many elements should we have that are in 4 of them?
4 of them. 2.
2 and the rest 0, okay? And let me tell you something. For example, we should only check 6, 5, 4, 3. We don't need to check 2 and 1, because for 2 and 1, for example, if S1, S2 needs more element, you can add, and it has no effect on the answer. So less than n over 2 is not important that it satisfies or not, because you can add as much as you want to those elements. Understand, or want me to explain this part?
You're just saying like 2. It's like if it's divisible by 4.
For example, if S1 intersect S2 is, for example, odd, because 2 should divide, you can add, for example, 1 element here. And it has no effect on S1, S2, S3, on the, for example, 4 subsets, 3 subsets, 5 subsets. So you can add elements to satisfy 2 as much as you want, then 1. Okay?
Yeah.
And it has no effect on the answer, because the answer only focuses on the number of elements that are in at least 3 of them. Okay? Okay. Now, by this case, you say, okay, 6 times 6 choose 6 plus 4 times 6 choose 5 plus 2 times 6 choose 4, right? It's the number of elements, and you say, okay, it is equal to 6 plus 4 times 6, 24, plus 2 times 15, 30, which is 60, which is exactly equal to 6 choose 3 times 3, right? But we should pay attention that it satisfies these things or not. Okay, 6 should divide S1 to S6, S2, S3, S4, S5, S6. What's this one equal to by this distribution?
Just 6 divided is just 1.
6, because we said
Or
6 elements for this, which
I
satisfies.
thought you meant, okay.
Okay, now 5 you should divide, because it is symmetric with respect to all of them, so we need to only take S1 to S5. S1 to S5 is what? Intersection of S1 to S5.
There's 4 elements.
No, 6 elements here.
Oh, okay.
Plus
10
4, which is 10, which is good, okay?
Yeah.
Now, for 4, S1, S2, S3, S4, it is exactly equal to what?
12 elements.
Okay, let's check. 6 elements here we should consider. S1, S2, S3, S4, here we should consider it because maybe we select this one or we select this one. So 2 choose 1 times 4 plus 2 elements here. So 6 plus 8, 14 plus 2, 16. Understand or want me to explain?
Yeah, I get it, because you can have S1, S2, S3, S4, S5, or S1, S2, S3, S4, S6.
Yes, you should add one more subset from S5 or S6. 2 choose 1 times 4 and then 2. Okay?
Okay.
And now, okay, for this one, use the same method to calculate S1, S2, S3.
Is it like basically 6 plus 3 choose 2 times 4 plus 3 choose 1 times 2?
Exactly. Oh, so it would be 6 plus 12 plus 6, which is 18, 24. Which satisfies all of them, right?
Yeah.
Okay, now we want to generalize this approach for S1 to S2n. S1, S2, S3, S2n minus 2, S2n minus 1, S2n. Okay, so how many elements should we have in all of them?
How many elements should be having all of them? Just 2n?
Yes, how many elements should we have in 2n minus 1 of them?
What should be, you want to get 2n minus 4 minus 2, 2n. So 2n minus 2?
Yes. How many elements should we have in 2n minus 2 of them?
This is 2n minus 1, this is 2n minus 2, this is 4 minus 2, 6n minus 3. 2.
Like if you use the pattern, as you can see, it is decreased by 2. Okay, so then we will prove it. 2n minus 2, 2n minus 4, 2n minus 6, right?
It's a 2n minus 4, 2n minus 6, yeah.
Yes, and then after that we will prove it. So suppose that, for example, we go all the way to, let's write Sn plus 1, S2n minus I. So how many elements? So in all of them, this, we have these things. Okay, how many elements do we have in S2n minus I of?
So that becomes 2n minus 2i.
Exactly. And how many elements do we have in Sn plus 1 of them?
Sn plus 1. So 2n minus 2n. Just 2?
Yes, and how many elements do we have in n of them?
0?
Yes. And let me tell you, here for the rest, first if you prove that n divides s1 into Sn, n plus 1 divides this, n minus 1, n minus 2, n minus 3 is not important, because then for s1 to Sn minus 1, you add as much as you want to satisfy that. And it has no effect on this part. And like this, you can satisfy all the rest. It has no effect on the final answer, right?
Mm-hmm.
Okay, so now here, there are two things to check. First, we should prove number of elements that we used is 2n choose n times n, right?
Yeah.
So we should prove 2n. Can you tell me number of elements that we use is sigma what if you want to write it in terms of sigma? And we want to prove why it is equal to 2n choose n times n.
Okay, so sigma I equals 0 all the way to n. And then, let's see. So I guess 2n minus 2i times... Well, this is just for 2n choose n, it's just for the number of at least 56. Okay. Times 2n choose I.
Yes, 2n choose 2n minus I or I. So you should prove why this summation is equal to this, okay?
Okay.
Try to prove it first on your own.
I can't figure out like even if there is a combinatorial argument for this.
Okay, so let me tell you how you can solve. Look, you should use, for solving this, you should use only this identity. R times n choose R is what times what?
R times n choose R, so n times n choose n minus 1 choose R minus 1, right?
Exactly, it means that you select a team, then a captain, or a captain, then the rest of the team, right?
Yeah.
Only just by using this identity, you can solve it. Do you need another hint, or is that enough?
No, it should be fine. You can't reduce it to the right answer.
Okay, let's check it together. So what should we do to this number to use this?
I turned it into 2n minus I, and then I did another minus I term.
But then we have two parts, right? And we
Well,
have
yeah,
2n minus I, and again, I is not good, right?
I guess not.
Instead of doing that, because we want to use this completely, so I write it as 4n minus 2n, okay?
Okay.
Then it would be 2 times this one, then we can use this one complete, right?
Yeah.
So it would be 2 times sigma I0 to n, 2n minus I, 2n choose 2n minus I, then we use 4n minus 2n times 2n choose 2n minus. Agree?
Yeah.
Okay. So let's but this 2 is not for these two, so let's write two parts here. I can write it as sigma I0 to n. So this part minus this. Okay, what can we do for this part?
Well, you can turn it into 2n, or 2 times the summation times 2n times 2n minus 1 choose.
Look, you can say 2 times, you can take this outside, 2n, right?
Yeah.
Times sigma I from 0 to n. What choose what?
2n minus 1 choose I.
2n minus 1 choose 2n minus I minus 1, right?
Yeah, which is
Or
I as
I,
well.
yes, that's correct.
Okay.
Okay, so here we have this minus 2n times sigma I 0 to n. 2n choose 2n minus I, right?
Yeah. Yeah. It's also
Okay, want to
I.
try the rest on your own?
Okay.
Let's check this one. The first one is 4n times 2n minus 1 for I0, it would be 2n minus 1, right?
Yeah.
Plus 2n minus 1, choose 2n minus 2, all the way to 2n minus 1, choose what?
All the way to 2n minus 1, choose. Well, it would be like the same as n. Be
n minus 1, right? Yes, n minus 1 or n. But because, look, we are considering these numbers. If you write n, we think that it is until n, but it is until n minus 1, right?
Yeah.
Okay, minus 2n times 2n, choose 2n, 2n, choose 2n minus 1, all the way to 2n, choose n, right?
Mm-hmm.
Okay, now let me ask you something. 2n choose 0 plus 2n choose 1 to 2n choose n minus 1 plus 2n choose n plus 2n choose n plus 1 plus all the way to, let me move it to left, all the way to 2n choose 2n is equal to what?
2 to the 2n.
Exact, 2 to the 2n. Now here we are counting from 2n to n. This
So
part.
2 to
So
2
first
to the
this,
2n minus 1.
so this part is what?
2 to the 2n minus 1.
No. Because look, we can say this part, if this part is a, this part is a, okay?
Oh, for this. 2 to the 2 to the 2n minus 2n, choose n over 2.
Yes, a is equal to 2 to the 2n minus 2n, choose n over 2, right?
Yeah.
Okay. So then what's this part equal to?
2 to the 2n plus 2n, choose n over 2.
2n, choose n over 2. By using the similar approach, what can we say about this one?
Let me think. It's 2 to the 2n minus 1 over 2 plus the last term is 2n minus 1, choose n minus 1.
2 to the 2n minus 1 over 2 plus 2n minus 1, choose n minus 1, right?
Yeah.
Okay, let's check. Plus, minus 2n times 2 to the 2n over 2 plus 2n, choose n, right?
Yeah.
Okay, if you can calculate, it's 4 2 to the 2n plus 1 over 2 2 to the 2n. So we can cancel this one and this one, agreed?
Yeah.
So it would be 4n times 2n minus 1, choose n minus 1, minus n times 2n, choose n, right?
Yeah.
And we want to prove y is equal to n times 2n, choose n, right?
Yeah.
Is it correct? Let's check it again to make sure it's correct or not. We said 2n minus 2i, for example, I0 minus 0, 2n, choose n. 2n choose 2n minus 1, 2n minus 2. So here I said we can write it as 4n minus 2n. So 4n minus 2i, it will be 2 times this, it's 2 times 2n minus I from 0 to this times 2n this. Then minus 2n times this sigma. So it would be, if we consider this one, 2n minus I times this would be 2n times 2n minus 1 times 2n minus I minus 1 minus 2n. times this. Okay, so it would be 4n times 2n minus 1, choose 2n minus 1, 2n minus 1, choose 2n minus 2, 2n minus 1, choose n minus 1, minus 2n times 2n, choose 2n, 2n, choose 2n minus 1, all the way. Okay, so is it correct or not? So we can divide both sides by, we can take it to right side. It's 4n, 2n minus 1, choose n minus 1. Why this one is equal to 2n times 2n, choose n, right?
Yeah.
So we can cancel by 2n, so it's 2, so 2 times 2n minus 1 factorial, n minus 1 factorial times n factorial.
Mm-hmm.
Why this one is equal to 2n factorial, n factorial, n factorial, right? So if we cancel this one by this one, 2n is left, this one by this one, then this one by this one, n is left, so it is correct, right?
Yeah.
Okay, so we proved this now. But suppose that, for example, we didn't know it is 2n choose n, and we reached to this part, right?
Mm-hmm.
So we can say 4n times 2n minus 1 factorial, n minus 1 factorial, n factorial minus n times 2n factorial over n factorial, right?
Yeah.
Here you can say, okay, for n, we can write this part as 2 times 2n factorial, right?
Yeah.
So we can factor from 2n factorial, n minus 1 factorial, n factorial. And you can also cancel this one, n minus. Okay. So we have 2n factorial, we have 2 here, 2 minus 2n factorial, 1 over n minus 1 factorial minus 1. So it would be this one. It's 1, so it's 2n factorial, n minus 1 factorial, n factorial. So you can multiply it by n and divide it by n times 200. Okay?
Yeah.
Okay. Now one part is left here. We should prove that. Okay. We should prove why 2n minus I divides S1 intersect S2 intersect S3 all the way to what?
2n minus 1.
2n minus I.
Yeah.
I is from
Yeah,
what to what?
I is from 0 to n.
Yes. Okay, from I0 to n you should prove it, right?
Yeah.
Okay, so try to find, you should calculate this in terms of n and I and prove. Try first on your own.
So what did we prove in the before? That
No, we didn't prove. We calculated all of them. And we proved
okay,
all of
cool.
them is 200. And here you proved, for example, this look like this one. We proved first it is 60. And for each of them we proved this, right?
Well, yeah. So what did we prove with the 2n choose n one? Or that
Which
n
one?
times 2n choose n? Like what did we prove with this?
It is sum of all of them. But maybe, for example, you want to say, okay, if you consider 2n minus 1 elements, what's S1 to S2n minus 1? It is not 2n choose n times n.
Oh.
The sum of all of them is this. But you should consider for each of them that the sum until that part is a multiple of, for example, 2n to n minus 1, right?
Okay.
Okay,
So prove that each like sum is a multiple of the 2n minus I.
exactly. You should prove this part, this sum. Let me show you here. You should prove if we calculate this in terms of n and I, then it is a multiple of 2n minus I. So you should first focus on calculating this, okay?
Okay. I'm not sure how to prove this either.
Okay, so let's try it together, okay? So here, let's consider part by part. First, we consider the elements that are in all of them. Okay, so let's consider S1, S2 to S2n minus I. How many times? What's the effect of this part on this?
which is plus 2n.
Exactly. Plus 2. What's the effect of this one, this part on this?
2n minus 2 times 2. 2n minus I times 2n choose I.
2 and choose I? No. Do you need a hint for this part times what choose what? Do you need a hint for this part that is what choose what, or want to find it on your own?
Yeah, I don't know. I don't know. I can't find it.
Okay, so let me tell you. Here, so for all of them, let me tell you, for all these elements, we have elements, but we have one cross here, right?
Mm-hmm.
This cross should be only in this part, right? Because if the cross is here, it has no effect on this, right?
Yeah.
So one cross here. So it would be 2, one cross choose 1, but what? 2n minus I, which is I choose 1. Understand?
Okay.
Okay. Now, what about the effect of this?
2n minus 4 times.
It's 2n minus 4 times what? Choose what?
I choose 2.
Exactly. And we can say the first one is I choose 0, right?
Uh-huh.
Okay, all the way to what are the last two terms?
All the way till the last 2 terms are just
Let's write last
2.
term first. Last term is what term?
0.
No. Look, last term is this one. That's the constant. 2n minus 2i times I choose I, right?
Mm-hmm.
Then what about the second last term? What times what?
2n minus 2i plus 2 times I choose I minus 1.
Minus 2i plus 2 times exactly. I choose I minus 1. Okay. Now you should use similar approach like this part that you use the r times this. Only by using this identity you can simplify it and prove that it is a multiple of 2n minus I, okay? Do you need another hint or is that enough?
I can try, yeah.
Okay, sure.
Okay, I proved it. So,
Okay, let's check here. I write it as a sigma 2n minus, for example,
I
2.
didn't have a sigma, but yeah.
Without sigma, yes, we can solve, but if we solve it with sigma, it would be I choose j from 0 to 2i, right?
Yeah.
Okay, and because I want to use j, I consider first 2n sigma j 0 to I choose j minus 2 times sigma j 0 to I, and then you can say j times this one is I times I minus 1, j minus 1. And here you can say j from 1, because when j is 0, this one is 0, right?
Mm-hmm.
So it would be 2n times what? What's this sigma equal to?
Should just be 2 to the I.
Exactly. What about the next one?
Minus 2 times I times 2 to the I minus 1.
Exactly. So it would be 2i, 2n minus 2i. Okay, 2n minus I times 2 to the I, right?
Yeah.
So it's a multiple of 2n minus I. So we proved this side completely, right?
Mm-hmm.
Okay, now we should work on this part, and I told you something last session. So let's work on this part. And let me first explain it for you for 4, 6, and so on. No. S1, S2, S3, S4. 1, 2, 3, 4. Okay, so do you agree this is at least 4?
Yeah.
And 4 divides this, right? Okay.
Yeah.
So I
Yeah.
remove 4 of them. Look, I remove 4 of them. I do this. I say, okay, instead of these 4 elements, I change them to 1, 2, 3, this one, 1, 2, this one, this one, this one. Okay, so I remove 4 elements and add these 4 elements. Okay.
Uh-huh.
And I want to say if this example satisfies the conditions of the problem, this example also satisfies. Okay?
Okay.
Agree this example also satisfies. Satisfies means divisibility.
Yeah.
When you change it for example, S1, S2, S3, S4, it is subtracted by 4, S1, S2, S3, subtracted by 4 and added by 1, right? -3. S1, S2 subtracted by 4 and added by what?
Subtracted by 4, add by add 2.
Exactly. So it's -2. So it's good, right?
Yeah.
Okay. So by this action, all the divisibility conditions are satisfied, right?
Yeah.
So because it is multiple of 4, we do it as much as we can. Then intersection of all of them would be 0, right?
Yeah.
Okay. Then we do the similar action for S1, S2, S3. How? S3, S4. So here, when I have, for example, 3, I know this is at least what? And look, let me tell you, we know it is greater than 0, right? Because here we know it's greater than 0, and for each of them we add S1, S2, S3. So now, do you agree we can say S1, S2, S3 is positive number of elements that are in exactly these are positive? Agreed?
Uh-huh.
And what divides these elements?
3.
3. Then you change it to what? S1, S2. You remove 3 of them, and then you change it to this one, this one. Okay.
Okay.
Now, let's consider it has no effect on S1, S2, S3, S4, right?
No.
No effect. What about S1, S2, S3? What's the effect on S1, S2, S3?
-3.
-3. So again, the condition is satisfies this, right? For example,
Yeah.
S1, S2, S4, 0, right? Has no effect. What about S1, S2?
-2.
-3 here, plus 1, -2. Again, it's good because 2 should divide this, right?
Yeah.
Okay, so if we do this part as much as we can, then we don't have any element that is in 3 of them, right?
Yeah.
So then all the elements are in 2 of them or 1 of them, right?
Uh-huh.
Okay, so then we can say S1, S2. And for example, if you have some elements in S1, S2, it is positive because why? Because first it was positive, then all elements in 3 of them positive, then because you do this for all of them, for each 2 of them, we have at least 1 element, right?
Yeah.
Okay, so we have positive for all of them, S1, S2, S3, S4, for all of them. And each of them, 2 divides that. So it is at least 2. So the number of the answer here is at least 4, choose 2. And when you do this, you don't change the number of elements. You remove 3 elements, you add 3 other elements, right?
Yeah.
So you don't change the number of elements. At the end, the answer is at least 4 choose 2 times 2, which is exactly 2n choose n times n. Understand?
Yeah.
Now we want to do the same thing for 2n elements. Okay? It means what? For example, at first, S1 to S2n, it is positive, and 2n divides that. You remove all of them, and then you add S1, S2, S2n minus 1, S2n. You add this part, then this part, all the way to this part, and this one. Okay, then we have 2n elements here, right?
Mm-hmm.
Okay, and you can consider delta is what, and you can prove it for general case. You can say, okay, S1, S2 to S2n minus I, S2n minus I plus 1 to S2n. In general, you can say, okay, we have some number of elements. It is positive. 2n minus I divides that, right?
Mm-hmm.
So you remove 2n minus I elements. This one is equal to 2n minus I. Then you move it to this S1, S2, S2n minus I minus 1, S2n minus I, S2n minus I plus 1, S2n. So this one, you change it. Look, it is this part. This is this part. Okay, sorry. You remove this one, all the way to this part. So let's write this one and this part. Again, these elements. Okay, so in general, you should prove after this action why all the conditions will be satisfied as well. Okay, so here, for example, suppose all the conditions are satisfied. After applying this action to the subsets, again, all the conditions are satisfied. Okay?
Yeah.
Try to prove it.
Okay. Just like prove that after each time you do this, that all the conditions.
Yes, I said for I. When you say for I, it's for in the beginning. I wanted to prove for example, 2n. But if you prove 2n, then 2n minus 1. At the end, you should prove for 2n minus I. Okay. So I is a general number. I can be from. Let me tell you. For 2n, I is from 0 to n minus 1. Okay.
Mm-hmm.
So, and you remove 2n minus I elements. You should prove y after removing these 2n minus I elements and adding these 2n minus I elements. If in the initial case all the conditions are satisfied by after this action, again all the conditions are satisfied.
Uh-huh. I don't know how to do it for like the smaller, for example, you take out 2n minus I, but then from S1 to S2n minus I minus 1, I don't see why that's necessarily true.
Were you able to prove?
No.
Do you need a hint?
Yeah, for 2n, yeah.
Okay, so look here. I want to consider the effect on, for example, S1, S2 to SK, okay? Which case from 1, let's say 2n minus I, right? And look, S1 to SK should be in this interval because it is, if it is on outside, some elements outside, it has no effect, this action, right?
Yeah.
So case from 1 to 2n minus 1. I want to see what's the effect. And here we can consider case at least n, because as I told you, only it is important to satisfy conditions all the way to n. Because for n minus 1, you can add as much as you want. And it has no effect on the, for example, S1 to Sn, S1 to Sn plus 1. And it has no effect on the answer, right? So I should consider this effect. So let's write it as delta. When you remove these elements, what's the effect on S1 to Sk, which k is from n2 to n minus?
We do S1 and SK for delta on which one? On the just S1 to SK? and you decrease that by k. Right?
It
Just
it has
isn't it just
it would
minus
be
k?
negative 2n minus I, right? Because of this, right?
Wait, I thought it's k. What are you defining k as then?
What is k? K is a general number, S1 to Sk, okay?
So why does it need to be 2n minus I?
Because when you remove those 2n minus I, it would be negative 2n minus I.
But I thought you were moving from S1 to Sk.
So we remove from k is from n to n minus I. S1 to Sk, for example, are these. When you remove these elements, so because of this, it has an effect, then you should consider this, right?
Okay.
Okay. Then what happens when we add the elements?
The delta of what? What is the delta? What is the change of
Delta
what?
means effect. What
Effect
happens
on
to
what? Effect on what?
effect on S1 to Sk? Let me see. Look, S1 to Sk, when I say, I mean what? S1, S2 to Sk. Okay?
Where k is between n and 2n minus I.
Exactly.
I don't get it. I just
So
don't
you should think.
understand.
Because look, for
Well,
when I explained this for you for 4, you should do the same thing for
yeah, but
2n.
I don't what this can you explain what k you're defining k as? You're doing I thought you're doing this function on
Look, for
2n minus
example,
I.
when I did this, what's this part? I'm doing exactly the same thing here.
Yeah, on s equals on like 4, S1, S2, S3, S4.
Yes. And we found the effect on S1, S2, S3, S4, S1, S2, S3, S1, S2 on all of them, right?
Okay.
So we are doing the same thing. So how you apply it? How you want to
Wait, so
prove
what?
for n? Because look, we should prove it for n. When I remove these elements, I want to prove all the conditions are satisfied. So what's your way to prove it?
I don't understand the variables. So you're saying I is just
Look, I remove these elements and I add these elements. Understand this action?
yeah.
So how can we prove under this action all the conditions are satisfied again? How can you prove it? What's your approach to prove it?
It's a function of k.
Yes, for example, you should prove after this action all the conditions are satisfied. Okay? All the conditions means what? Means 2n 2n divides s1 to s2n intersection of them. And we know this action has no effect on s1 to s2n, right?
Mm-hmm.
If I is at least 1. So it has effects on s1 to s2n minus I, s1 to s2n minus I minus 1, right?
Mm-hmm.
Okay, so we cannot prove all of them. We should consider a variable here and prove it in general. That after this action, this one again is multiple of k. Want me to explain or want to review more?
So it's for any k, it's minus 2n minus I plus 2n minus I minus 2.
Minus 2n minus I is correct, but plus what?
2n minus I minus 2. Or not minus 2, but like minus k. Or not k.
So here you
Like
should
for
think. Plus,
I'm
your
trying to
minus is correct.
I'm saying
What's
for like S1, S2, for example, you would have to subtract 2 because there's two x's. There's like two like of those cases where there's x's in both of them.
we have one x. So if you want to find the effect on S1 to SK, all of them should be here. Then you should have one cross here outside in this interval.
I'm saying for S1, S2, I'm trying to give an example. Trying to
For
tell
S1,
me,
S2.
like,
Okay, so let's. You consider K is 2.
yeah,
Okay, when K is 2,
it's
it would be minus 2n minus I plus. So in all of them, it is good. You add, you add, you add. In all of them, it's good, except these two cases, right?
yeah. So then I subtract 2 again.
So
So
yes,
I add
this,
2.
because this cross can be here or here or here, all the way to here. It is this one. 2n minus I minus 2. Choose one, because you should select one cross, or you can say 2n minus I minus 2. Choose one. You are selecting where is the cross.
Mm-hmm.
Understand?
Mm-hmm. Well, with the choose one, but the X. Why is it choose one? Why are you
Because
choosing
one
one?
cross, look, if the cross, we have one cross in this interval. This cross should be from S3 to S2n minus I. Okay, so one cross.
Okay.
Understand?
Yeah, but isn't it always one cross in the interval outside? 'Cause
Can I say it again?
isn't there always just one cross?
Yes, because you remove S1 to S2n minus 1. Yes, only one cross. The cross is here. This is the cross that you create.
Yeah, there's only one cross in like each row. So I don't why isn't it always just choose one?
Yes, the action is this. You remove elements, for example, 2n minus I elements that are in 2n minus I. Then you add elements like this. You add exactly one cross. Okay?
Yeah.
So now for case, see what happens.
So it's still minus 2n minus I plus 2n minus I minus 2, or not minus 2, minus k, choose 1,
Okay, minus 2n minus I plus what?
plus 2n minus I minus k, and there's still one cross, right? So it's just
2n minus I minus k, exactly one cross. So simplify it.
it's just minus k.
Okay, minus 2n minus I, it would be minus k. So it is good, right? Because
Yeah.
when k divides this, the effect is minus k. So again, k divides that, right?
Yeah.
Okay. So we prove this now. Okay, so we use this action, right? We use this action and we proved all the conditions are satisfied again, right?
Yeah.
So you do this until this part. You do this to make this one equal to 0, make si1, for example, to si2n minus 1 equal to 0. You do this until si1 to sin plus 1 equals 0. Then we know for si1 to sin, it is greater than 0, right? We don't do this action for 1 to n, for n subsets, okay?
Uh-huh.
Then each of them is positive, and we know that n divides them, so it would be 2n choose n times n elements. Answer is at least. And by this action, you didn't change the number of elements.
Uh-huh.
Okay, understand?
Yeah.
Okay. So we proved this problem complete, right?
Yeah.